Today we're going to be looking at the nth term. I'm going to go through an explanation of what the nth term is and of the methods we use to solve problems involving the nth term. Then we're going to look at some worked examples and some practice problems for you to try yourself. So firstly, the nth term is basically just a convenient way of expressing patterns within sequences in terms of the letter n, where n represents the position of a number within its sequence. So to illustrate what I'm talking about, if I just start with the simple sequence 5, 8, 11, 14, and then I assign each of these numbers with its n value. So if I just write the row of n values, the n value of this 5 is a 1 because it's the first number in the sequence. The n value of this 8 is 2 because it's the second number in the sequence, 3 because it's the third number in the sequence, and 4 because it's the fourth number in the sequence. So then the idea is to get an expression of the nth term, which is to describe this sequence of numbers in terms of these positions. And of course, both of these go off into infinity for as long as you like. The whole idea is such that if I were to then ask you what the 100th term in this sequence is, you would immediately be able to tell me without having to write out 100 numbers. So first of all, you'd look at try and establish something called the common difference. So if you look at the first two numbers, you can see that to get from 5 to 8, you add 3. To get from 8 to 11, you add 3. To get from 11 to 14, you add 3. So you can immediately see that the common difference is positive 3, plus 3, whichever you like to say. So the first thing you write is 3n. So that is 3 multiplied by n is the first thing you write. Your common difference times your n. Then you have to look at what your correction factor needs to be. Now, the best way to explain this is if I let n equal 1, you can see that this will give me 3 times 1, which is 3, whereas in fact we want 5. So to get from 3 to 5, I have to add 2. Now we can check. If we take n equal to 2, this will give me 3 times 2, which is 6, plus 2 will give me the 8. 3 times 3 is 9, plus 2 will give me the 11, and so forth. So we can see that this is correct. This is the first and most popular method of doing nth term problems, but for doing simple nth term problems such as this, there is another method, and it's the equation method. So if I just write out the equation first of all, we can say that the nth term is equal to dn plus a minus d, where d equals the common difference, which in this case, as we established, is plus 3. A is the first term in the sequence, which in this case is 5. And now if we plug these numbers into here, we end up with 3n plus 5 minus 3, which gives you 2, which is of course the same answer. Now this method is much more preferred because it can be applied to any complexity of problem, whereas this formula is only directly applicable to simple problems such as this. One other type of problem I wanted to explain is the fact that the nth term may not always be linear. Now what that is to say that it may not always just be 1n. So when we write n, what we really mean is n to the power of 1. It's just n. This is a linear problem, whereas it is possible to relate sequences in terms of n squared, or n cubed, or n to the 4, etc., etc. However, within the scope of this course, you only need to worry about these two. So this is linear, and this is not linear, and that's all you need to know for this course. So to illustrate what I'm talking about, I'll just give you this sequence: 2, 5, 10, 17, So now the first thing you do in every problem is write out your corresponding n values for clarity. So that's 1, 2, 3, 4. And now if you try and establish a common difference, what you will see is that to get from 2 to 5 you have to add 3, but to get from 5 to 10 you have to add 5. And this should immediately ring alarm bells, because plus 3 is not the same as plus 5, is not the same as plus 7 to get to this 17. So this should immediately tell you that this is not a linear problem anymore, because these common differences are different. So then you write out your n squared. You will write out a row of n squared values where you just square these numbers here. So you'll get 1, 4, 9 and 16. Now, if you compare these two rows, it's easy to see that to get from 1 to 2 you add 1, to get from 4 to 5 you add 1, to get from 9 to 10 you add 1, and to get from 16 to 17 you add 1. So you can say that the nth term of this sequence is n squared plus 1. And the equation that we've seen before, the equation method, doesn't hold up in this case, which is why this look at it and work it out method, as I call it, is much better. So now if we move into some example problems. So first of all, if you get faced with this in an exam situation, find the nth term of the following sequence. The first thing you do is write out your n values. 1, 2, 3, 4, 5, 6, simply up to however many numbers you are given in the problem. Then the second thing you do is you try and establish a common difference. To get from 11 to 15 you add 4, to get from 15 to 19 you add 4, to get from 19 to 23 you add 4, and so on. And because it is plus 4 each time, you know that this is a linear problem, because it's the same each time. So now the first thing you write is 4n, and then you put your first n value in, 4 times 1. You see that that gives you 4, which is not equal to 11, so then you have to work out what your correction factor is, and to get from 4 to 11 in this case, you add 7. And then you can check the other numbers. So you set n equal to 2, this gives you 4 times 2, which is 8, and then 8 plus 7 is 15. 4 times 3 is 12, add 7 is 19. 4 times 4 is 16, add 7 gives you your 23, and so on. So you know this to be correct. For the sake of completeness, I will just use the formula method as well. So the nth term is equal to dn plus a minus d. D here is equal to the common difference, which is 4, and a here is equal to the first term, which is 11. Putting these numbers into this equation, you end up with 4n plus 11 minus 4, which is 7, which is of course the same. So now if we move on to the next example. Again, first things first. Find the nth term of the following sequence. The first thing you do is write out your n values. 1, 2, 3, 4, 5, 6. Second thing you do is establish a common difference. So to get from 25 to 21, you minus 4. To get from 21 to 17, you minus 4. To get from 17 to 13, you minus 4. 13 to 9, you minus 4. 9 to 5, you minus 4. Again, because all these are the same, you know it's a linear problem. And now the first thing you write is minus 4, being very careful to include that minus. It's a common error amongst students to think, well, the common difference is 4, so I'll just write plus 4. But in reality, you need to include the actual operation needed to get from one number to the next. So, as I say, the first thing you write is minus 4n. Then you look at n equal to 1. Minus 4 times 1 is minus 4. To get from minus 4 to 25, you have to add 29, and that is your correction factor. So we can check that. put n equal to 2, you get minus 4 times 2, which is minus 8. Add 29 gives you 21. 3 times minus 4 is minus 12. Add 29 gives you 17. 4 times minus 4 minus 16. Add 29 gives you 13, and so on. Now again, for the sake of completeness, I'll use the equation method. dn plus a minus d. d here is equal to minus 4, again taking care to include the minus. A is equal to 25, the first term in the sequence. So now plugging this in, you get minus 4n plus, and now be careful, because here you have a minus minus, so it is 25 minus minus 4, which is of course 25 plus 4, which gives you 29. And these are of course the same. So moving on to the next example. So again, first thing you do is you put your n values down, 1, 2, 3, 4, 5, 6, and then you try and establish a common difference. From 2 to 5 is plus 3, from 5 to 10 is plus 5, and now immediately an alarm bell should ring in your head because plus 3 and plus 5 are different. So this means that this is not a linear problem. You can keep going because this is now plus 7, this is plus 9, and this is plus 11. So now, because these are not the same, you know that you now need to write out an n squared row, which is 1, 4, 9, 16, 25, 36. And just as I previously explained, you can now compare these two sets of numbers and see that to get from 1 to 2 you add 1, from 4 to 5 you add 1, from 9 to 10 you add 1, and from 16 to 17 you add 1, and so on and so forth. So you can say that the nth term of this sequence is n squared plus 1. And you cannot use the you cannot directly use the equation method that we have before shown, which is why this look at it and work it out method is preferable. It also will save you time in an exam. Next, this is a slightly different type of question now. We're not being asked to find an nth term, we are given an nth term, and then we are told to determine whether these numbers in turn are part of this sequence. So remember, whenever you see an nth term, you have to imagine and realize that it is simply an infinite number, an infinite sequence of numbers rather. So to determine whether these numbers are in that sequence, there is a very simple method and there is a more time-consuming method, and I'll show you both and you can make up your mind which you wish to use. So first of all, the simpler and quicker method is simply to realize that n has to be a whole number. It cannot be anything other than a whole number, because if you think about it, what it physically represents is a position, and you cannot have a, for example, 4.5 position. You can have a 4th position and you can have a 5th position, but you cannot have a 4.5 position. It simply doesn't make sense. So using this knowledge that n must be a whole number, you can simply set your nth term equal to the number that you want to, that you're interested in finding out whether it is in this sequence. So we'll start with 15, and we will say 3n plus 9 is equal to 15, and this will give you that 3n is then equal to 6, which will then give you that n is equal to 2. Here I've simply minus the 9, and here I've simply divided by 3. And here we can see that n is a whole number, so we can conclude that 15 is in fact part of this sequence. If we look at the next one now, the 23, 3n plus 9 equal to 23. Minus the 9 from both sides, you get 3n is equal to 14, minusing the 9. and then you get n is equal to 14 divided by 3, dividing both sides by 3. And now you can see that 14 is of course not divisible by 3, so therefore this is not a whole number. So therefore you can conclude that 23 is not part of this sequence. The next one is 3n plus 9 equal to 24. This gives you that 3n is equal to 15, which gives you that n is equal to 5. Here I've just minus the 9 from both sides, and here I've just divided by 3 on both sides. 5 is of course a whole number, so you can conclude that 24 is part of the sequence. Now if I do the last one, which is 3n plus 9 equal to 34, this will give me that 3n is equal to 25, which will give me n is equal to 25 divided by 3. 25 is not divisible by 3, therefore this is not a whole number. And therefore you can conclude that 34 is not part of the sequence. So, to reiterate, because this gives you a whole number for n, you can conclude that 15 is part of the sequence, and because this gives you a whole number for n, you can conclude that 24 is part of the sequence. Whereas, because these do not give you whole numbers, you can conclude that 34 and 23 are not part of this sequence. Now, the second way of doing these types of problem that I talked about is simply you write the nth term and then you write out a line of n values. So if I just go to 5, of course you can go as far as you like, but if I just go up to 5 for now to illustrate the method, you simply just plug in these numbers one by one. So 3 times 1 is 3, plus 9 gives you 12. 3 times 2 is 6, plus 9 gives you 15. 3 times 3 is 9, plus 9 gives you 18. 3 times 4 is 12, plus 9 gives you 21. 3 times 5 is 15, plus 9 gives you 24. And I will need a few more numbers here, so if I just go 6 and 7. 3 times 6 gives you 18, plus 9 gives you 36. So I actually only need to go up to 6. This demonstrates why this method isn't particularly as good, because in reality, until you start doing it, you don't know how many n values you will need. And so you could end up going up to n equals 11 or 12 or even further, in which case this method becomes extremely time consuming, which in an exam situation is not a good thing. However, from this, you can now see that 15 is part of the sequence and that 24 is part of the sequence. But 23 and 34 do not appear in this sequence, so you can again conclude that these are part of it and these are not, as was previously found. So going on to the next practice. So this is where you can now pause the video, have a go at this question on your own, and then play the video and I will go through the answer. So, first things first, establish your n values, 1, 2, 3, 4, 5 and 6. Secondly, you try and establish a common difference. So here you add 7 to get from 23 to 30. To get from 30 to 37 you add 7. To get from 37 to 44 you add 7, and so on and so forth. Now, because all these are the same, you can conclude that this is a linear problem. So then the next thing you do is simply write 7n. That's positive 7n. then you have to try and establish your correction factor. So if you set n equal to 1, this will give you 7. But what you actually want is 23. So you need to think about how do you get from 7 to 23? You add 16. Yes? So then you can check this. So set n equal to 2, that will give you 14, 7 times 2. 14 plus 16 gives you 30, which is correct. 3 times 7 is 21. 21 plus 16 gives you 37, and so on and so forth. So you can see that this is correct. For the sake of completeness, you can also use the equation in this instance because it is a simple problem, a minus d. So then you say d is equal to 7, your common difference, and a is equal to 23, your first term. So then you say your nth term is equal to 7n plus 23 minus 7, which is 16, which is of course the same as this. So now we have one practice question left, which is slightly trickier. So again, feel free to pause the video and play it to see the worked example when you've finished. So again, first things first, n values 1, 2, 3, 4, 5, 6. Secondly, try and establish common difference. Minus 4 to minus 1, you add 3. Minus 1 to 4, you add 5. Now immediately alarm bell should ring because these are not the same. Therefore you know this is going to be a non-linear problem. So then you continue. 4 to 11 is add 7. 11 to 20 is add 9. 20 to 31 is plus 11. So because you know that this is not a linear problem, your next step is to write out your n squared values. So that is 1, 4, 9, 16, 25, and 36. Now of course be careful that you are in fact squaring your n values when you write out this row, not your sequence values. That's another common error. You have to be careful that you are in fact calculating n squared. So now you look and try and establish a difference between this row and this row, your actual sequence. And it's quite easy to see that it's simply minus 5. To get from 1 to minus 4, you minus 5. To get from 4 to minus 1, you minus 5. To get from 9 to 4, you minus 5, and so on and so forth. So you can now determine your nth term for this sequence is n squared minus 5. And it's as simple as that. If you have any questions or queries, feel free to drop them in the comments below and I'll try and get back to you. Thank you very much for watching.